1K concept and basic calculus. The product rule of differentiation.
If you've ever wondered how to differentiate two functions that are multiplied together, and this is exactly what you need to know. The product rule helps us to break down those tricky expressions and make solving them easier.
So, whether you're brushing up for a test or just trying to understand calculus better, stick up with us. We'll explain, go through an example, and show you how it works by step. Alright, now let's solve the problem using the product rule.
Our first equation is x is equals to 6x to the power of 6 plus 2x to the power of 4 plus 8x to the power of 6. This is a perfect example of two functions being multiplied together. The product rule says quantity of fg prime is equals to f prime g plus fg prime. That means we'll treat the first part, 9x to the power of 6 plus 2x to the power of 4 as f of x. And the second part, 9x to the power of 6 is g of x. Before we even apply the product rule, we first need to find the derivatives of our two functions. They are called f of x prime and g of x prime. Basically, they're the slopes of f of x and g of x at any point. Let's go back to the original function. Y is equals to 9x to the power of 6 plus 2x to the power of 4 plus 8x to the power of 6. We split this into two parts. F of x is equals to 9x to the power of 6 plus 2x to the power of 4. Then, the g of x is equals to 8x to the power of 6. Now, we take the derivative of each one term by term using the power rule. Power rule says, if you have a term like ax to the power of n, its derivative is at a times n times x to the power of n minus 1. So now, let's find the fx prime and the gx prime. So, first, let's do the f of x. So, our f of x is equals to 9x to the power of 6 plus 2x to the power of 4. So, next, we have to multiply it. 9 times 6x to the power of 6 minus 1 plus 2 times 4x to the power of 4 minus 1. So, now, let's solve the f of x. So 9 times 6 is equals to 54 and 6 minus 1 is equals to 5. Then 2 times 4 is equals to 8 and 4 minus 1 is equals to 3. Our fx prime is 54x to the power of 5 plus 8x to the power of 3. Now let's proceed to the g of x. So our g of x is equals to 8x to the power of 6. 8 times 6x to the power of 6 minus 1. And let's multiply it to find the gx prime. So 8 times 6 is equals to 48 and 6 minus 1 is equals to 5. So our gx prime is 48x to the power of 5.
Using the formula of product rule, which is f of x times g of x prime plus g of x times f of x prime. Our f of x is 9x raised to the power of 6 plus 2x raised to the power of 4. And our g of x prime, which is 48x raised to the power of 5 plus g of x quantity 8x raised to the power 6 and f of x prime, which is 54x raised to the power 5 plus 8x cubed. Now, all you have to do is apply the distributive property. 9x times 48x is 432x. And add the exponent 6 and 5, that is 11. 2x times 48x is 96x. And add the exponent 4 and 5. The result to 9. And continue the process to the another value of g of x times f of x prime. 8x times 54x is equal to 432x. Add the exponent 6 and 5, it will be 11. 8x times 8x is 64x. And add the exponent 6 and 3, which is 9. Next, we need to arrange it by its exponent. 432x raised to the power of 11 plus 432x raised to the power of 11 plus 96x raised to the power of 9 plus 64x raised to the power of 9. Next, we need to add the number who got the same exponent. So we have 432x raised to the power of 11 plus 432x raised to the power of 11 is 864x raised to the power of 11. We don't need to add the exponent. Next, we have 96x raised to the power of 9 plus 64x raised to the power of 9 is 160x raised to the power of 9. So our final answer is y prime equals 864x raised to the power of 11 plus 160x raised to the power of 9. That's our final answer.